Welcome everybody. Welcome to OpenStack or containers. It's a bit of a mix. I actually sent it. Hey, Monix, how are you? Hey. Sorry. I sent in a technical track with demo, but they moved me into the business side of the program, so I'm going to mix it up a bit. My name is Pieter Jenniskens. I'm a sales engineer for SUSE. You've met my colleagues earlier today. I've been working for SUSE since February this year, and before that I did Linux consulting basically my entire life. So I'm basically a technical guy that now works in sales. So I'll be talking to you about OpenStack and containers. Everybody knows OpenStack. Are there people working with containers yet? Some? Okay. Yeah. Are you running it standalone or just Docker or Kubernetes? Kubernetes? In OpenStack or outside of OpenStack? Okay. Okay, well, I'll be talking about containers, microservices, OpenStack, Kubernetes, and these things. So, this is what everybody's talking about. IT infrastructure, we need to change. We need to go more to clouds, more to containers, more to microservices, more to DevOps. How are we going to get there? What are the challenges, and why do we need to get there? Now, why do we need to get there? Because we want to do... Oh. Hello. No problem. We want our businesses to be able to adapt quicker to the market and spend more time doing the things that our businesses want to do. So if you design a cool app that does something cool for the world, that's going to save the world, then you want to be working on this app. You do not want to be working on maintaining infrastructure or maintaining all kinds of other things that are not your core business. So that's why a lot of companies are going to clouds and automation, so that it takes away a lot of the trouble, because clouds and automation are self-healing, and they through self-service they enable the developers and the core people in the business to do their core jobs and not worry about the rest. So OpenStack is the main product that everybody's talking about nowadays. These are the key components in OpenStack. Hey, Ivan. Is everybody familiar with this? Are people familiar with the technical side of OpenStack? Nope. Nope? Okay. Any people have seen these services and are familiar with it? Yeah, half of the crowd. Okay. So OpenStack is a infrastructure as a service. It's built up of several components. These are the 6, I would say, major components, the most important ones. These are not the ones we're going to talk about, but please make a picture.
Yeah, it's good to know.
Yeah, it's good to know. So OpenStack is infrastructure as a service. These are the things that you can hey, Jocko. These are the main components, but these are not the things that help you build containers. So outside of these 6 main components, OpenStack is a lot more. And every half year, a lot more services get added. So this is what's currently in SUSE OpenStack Cloud 7. You'll see this, what should be dark green, are actually services that are in SUSE OpenStack Cloud 7 and are fully supported, and we will give you support and updates and everything, and we will say, okay, this service is enterprise ready. If you use this service, we will vouch for it, and you can run your bank or your hospital or whatever on it. It's okay. Hey. So then we've got the lighter green ones. These are tech previews. These are relatively new services. These are being developed by the community. You can use them in SUSE OpenStack Cloud 7, but they're tech preview, so they might break. We will not vouch for it until you can run your hospital or your bank on these services. One of the newer services that is actually fully supported is CaaS. So that's containers as a service. So you can run your containers in OpenStack Cloud. There's some other cool things that are in SUSE OpenStack Cloud 7, but the main important thing is Magnum support for Docker orchestration. The other things we'll skip for now. So once you have your software-defined data center, it will look like this. You've got your physical infrastructure. On top of that, you've got your operating system, preferably SUSE Enterprise Linux, obviously. Then you've got your virtual server storage networks, and that will enable you to do a lot of things. We'll be talking about the containers bit, but you can also run Next to your containers, you can run other things like infrastructure as a service or big data or platform as a service. We'll be talking about the containers. So having this will enable you to, on one side, run the traditional OpenStack things, the virtual machines, what Gartner and all the other guys call mode 1, so normal virtual machines. And mode 2 is containerized application development, what they call mode 2, where buzzwords like agile, DevOps, continuous integration, continuous development are being used a lot. If anybody has any questions, just shout. It's better than waiting till the end. So what are the main things that containers enable you to do? They enable microservices. Has anybody heard about microservices? Yes. Is anybody actually developing microservices? Yes, some people, okay. Most people want to go to microservices but still have legacy software that's big heaps of software, yes? Okay, okay. When was your software developed, if I can ask? When was the...
Before I was born.
Yeah, okay. Do you work for a bank? Ah, okay. No, that's okay. I mean, that is typically the case. I'll talk about microservices now and explain what it is. I'll skip this because pictures are better than text. So this is your typical software that's been run by the mister in front here, works in a bank, has software, has been created 20 years ago or more. It's just one huge blob of software. It can be either C or Java. Well, Java's not that old, but usually it's just one really big blob of software that you can see here in the middle, and all the other external software bits talk to this one really big blob that does everything. And it runs on your mega mainframe machine, and it costs lots of money, and it can never go down, because if this goes down, basically everything goes down, your entire company is down, so this is bad. This is why we can't patch, this is why we don't get reboot times, this is why we don't get maintenance windows, and this is why we have the trouble that we have in IT at the moment. I mean, I think everybody knows these. So the better way is microservices. So instead of having one really big blob of code that does everything, you get containers, which are just small blobs of code that talk to each other via REST APIs. So yeah, as you can see here, your passenger management, your payment, your billing, and everything is one big piece of code. If passenger management needs to be patched or updated, there's a very big chance that driver management will die. Because, yeah, we didn't know about this function or this call or whatever. It always breaks. So the new way of working using containers is this. Every little bit of code is its own standalone container. It has several advantages. Containers in themselves have the advantage that it's a container, it's a self-contained piece of software that is so standalone that if a developer develops it on his laptop, it will work exactly the same on his laptop as it works in the data center. So you can make your developer, you can get one developer and make him the driver management developer. So this guy makes the driver management container. He makes it on his laptop, it works exactly the same as in the data center, and he's responsible for that. If he wants to update his driver management container, that's okay. Because everybody talks through REST APIs, so it's a language that has been agreed upon. The APIs don't change. If he upgrades his driver management, just this bit gets upgraded and the rest just stays the same. Another big thing that you can do with this is scalability in a completely different way than you did before. If you had this and you needed more, let's say your passenger management was going berserk because it's summertime and everybody wants to go fly to Aruba, let's say. If you want to scale this, you need to scale the whole thing. So you get like super mega big computers just because there's lots of passengers. In this case, if you have containers, you just only scale the containers. You scale the passenger management container. So you make sure you have 50 passenger management containers and maybe a few more payments, but maybe you don't need driver UIs at the moment. So everything is independent of each other. That's why microservices are really good. And also because you have 50 passenger management containers and not just 3 really big machines, and the passenger management developer has a new container, he can upgrade one of his containers, see if it works, and then slowly upgrade all the other 49. So it's completely independent. Upgrades can take place in bits of the infrastructure and it doesn't influence the rest. So this is why you have the continuous integration, continuous development. The developer can continue developing his bit and deploy his bit without actually affecting the rest.
But before you can scale it, you must have a load balancer in front of it, because otherwise the application does not know how to access the REST API. Is that
yes. Yes, but that's going to be a bit too technical. Okay. We're just going to stick to...
So it seems logical, but it has a lot more components.
There's a lot more components. Basically, all the containers, they announce themselves to it's not on this map. They say, okay, we've got so many containers doing this service, and if another container wants to talk to that container, it will ask this service, like, where is the container that does this? And then it gets an address and talks to that. So within Kubernetes, that's being taken care of. That's why Kubernetes is so cool. We'll get to that in a couple of slides. All these are things I just talked about. I think I explained most of them, so we can skip that. So why a container orchestration tool? So you've got your containers. SUSE has taken care of this for the normal Docker containers. It is supported in SUSE Enterprise Linux, just as in all other Linuxes, but then you have one container. So if you just have one container, you're still managing your containers, you're still writing all kinds of scripts to deploy your containers and start your containers and stop your containers and all kinds of things. A question? I thought you were looking, you needed.
I'm taking all of these.
Oh, okay, good. So yeah, it might be a bit much because we've only got half an hour. So let's see how much time have I used already. 12 minutes. Interesting. Okay. So that's where Kubernetes comes in. It will provision your containers. So through scripting, you can say, this is my whole set of containers for this program. So all the things that we just saw in the microservices, it will provision all of these. It will manage them if you have several VMs, or in this case VMs, because we're talking about OpenStack, and one of them dies, or one of your hardware bits dies. That's okay. Kubernetes will take care of it. If you have specified that you need 10 containers, Kubernetes will make sure that if 2 of them die because of whatever reason, it will spin up another 10. You can tell Kubernetes, if it gets too busy here, spin up more. And part of the management is also what Jocko is talking about, making sure they can find each other, making sure that they know what services are where. Automation, I talked about that. Host services, DNS, load balancing, it can all be done in Kubernetes. Security, yeah, I'll skip that bit. So, yeah, well, Kubernetes, you can have a multi-tenant and multi-user and all kinds of access groups in Kubernetes, but that's not that relevant at this moment. It's a big list of things. Because we don't have that much time, I'm going to skip it. I'll give you about 10 seconds to read it. But it's just the typical things that you can think of if you have to manage all these small containers yourself. That's not nice. So then we have Kubernetes. Kubernetes is a bit, at the moment, it's the tool of choice for container management. As it has been stated before, it's been developed by Google, then made open source, and everybody's using it at the moment. Cloud Foundry is it's more of a platform as a service. OpenShift is Red Hat's version of Cloud Foundry, and Mesos and other things are also very nice container orchestration tools. They work really well. It's just that in the market we see more Kubernetes at the moment, and we've chosen Kubernetes to use it with OpenStack for container orchestration. What does Kubernetes do? It basically does the things that I just said, a container orchestration tool. So in Kubernetes, you get masters and minions. Kubernetes itself is not easy to set up. It's actually a quite complex tool. But that's why we come in and other distributions come in and make it easy for you to set up Kubernetes. So you've got a Kubernetes master and you've got your minions. In your minions is basically where the workload happens. You've got pods, and pods are containers that should be together on a piece of hardware. So if you've got let's say a web server container and a database container, and they need to talk to each other a lot, then you want to have them in the same pod so they are always in each other's neighborhood hardware-wise. So.
It sounds contradicting what you said before, because the container can die, you don't care, right? and then they're still together, but they can find their way to another, only if they die within their own pod.
Yes, you're right. It's a bit contradicting, but it depends on the service. Sometimes you want to have them split, and sometimes they really need to be close to each other, and then they're in a pod. So
you can spin up new pods on other resources, so
yeah, so
it's a logical grouping.
correct. Yeah, what I said, if a container dies, it will be spun up somewhere else. That also counts for pods. Like if a pod dies with some important things, the pod gets spun up somewhere else. Or if a web server always needs a database server on a one-on-one relationship, then they always get spun up as a pair. Maybe web server, database server is not the best example, but there's things that are always coupled, and they always need to be on the same hardware, so they get into a pod. Some extra services like storage and things, extra Kubernetes, Docker kind of services that you wouldn't actually call the programmer also in the pod.
And these run on bare metal? Do they run on a hypervisor?
Well, in this case, we're talking about Kubernetes in OpenStack. So this runs on a virtual machine in OpenStack. Wow, the colors of this slide really messed up. Some features of Kubernetes, it's open source, it's written in Go, it's part of the cloud native, whoops, where's my cloud native foundation? So cool. It's just a really cool tool. Let's forget it. So, oh wow, the colors are really, is that visible that it's 3 colors? Yeah, I guess so. So basically this is what Kubernetes takes care of for you. So you've got the bottom layer, it's infrastructure as a service in this case, because we're at an OpenStack convention, it's OpenStack. And then there's all these things that Kubernetes takes care of with your containers, and then your team can just do DevOps and can work on the things they want to work on, the world-saving app that's going to be the next breakthrough. So you want your programmers to do smart things. You want your programmers to be working on the things that they are good at, the core business of your company. And you don't want your programmers or your other smart people to be managing all kinds of containers and fiddling around with that. So who is familiar with OpenStack Heat? A couple of people. Okay, most people have heard about OpenStack. It's infrastructure as a service. You can deploy virtual machines, you can deploy networks and load balancers. What Heat does, it makes templates. So you can template a couple of virtual machines or virtual machines and a load balancer and a network. You can put them in a template and you can deploy them. So if this gentleman over here wants to have his load balancer with 2 web servers and a database server, you can make it a template. And then Simon over there thinks, oh, I want one as well because I want to test something else. You've got the template, you just spin it up, and you can give everybody the same template, and you can remove it as a template. So once you're done with your testing, you just remove it. This templating service is then used by Magnum to talk to Kubernetes and Docker. This is a bit of a confusing picture, but basically on the control node, you've got your OpenStack Heat doing all the templating, talking to all the important services, and they spin up a Docker Kubernetes cluster on Nova instances. So like even just asked, basically you have lots of virtual machines. On top of that, you get, I can draw this. Oh no, I don't have a pen that works. Okay, never mind. So you've got lots of virtual machines. On top of that, you've got one big Kubernetes cluster, and then you've got a blob of containers.
Can you explain what the relation is? Because you have your physical infrastructure, OpenStack, and then you have Kubernetes, where you say, oh, I want so many
Yes.
of this to rerun and automatically spin up and scale out. And how can you see the relation to what you define there with regard to what you use in the lower part of your infrastructure? Because you can't overcommit at one moment. It's a traditional, and the traditional guy, right? So we scale for peak, and then you have this where you just say, oh, more, but at some moment your bare metal is out of resources, and then how can you see this?
Simon looks like he wants to answer. You want to answer, Simon?
Hi, it's Peter. Hospital class in English term.
No, you don't have to. I thought you...
The sequel would be some visibility like the monitoring solution Manasco that we were talking about earlier.
But it's on the outside, right? Then it's already...
Well, you build the scale capability in on the integration from Magnum to Kubernetes, and then you make sure the resources underneath can cope with the extra scale as it's being demanded.
So there's 2 things. Sorry to interrupt, Simon. first of all, in OpenStack you've got quotas. So I can give you a certain quota. I can give you I'll give you 10 CPUs and I'll give you 20 gigs of memory. Then, yeah, you want some more? Okay, you're going. Okay. So then,
big application, right?
yeah, okay, it's a big application, so you get a lot more. So then you deploy your virtual machines that run Kubernetes. These virtual machines have a size specification. So the virtual machines have certain CPUs and memory. And adding these up cannot go over your quota. So that's what OpenStack takes care of the fact that you cannot go over your quota with the virtual machines that you're then going to use for Kubernetes. Then you have your Kubernetes cluster. And within Kubernetes, there's also these things in place. So you've got your Kubernetes cluster, and then you're talking to your Kubernetes cluster, and you go, oh, I want to spin up this container and this container. And it will say OK until it's full. So there's 2 layers of capacity management.
Those guys on top of your pyramid still have to talk with the guys downstairs if they need more. And well.
Yes, yeah, correct. But Simon is also correct. If you have a proper monitoring tool in place, you can see in advance. Also, in OpenStack, you've got telemetry. You can see how much is being used. You can see how much of your quota you're actually using at this moment. And within Kubernetes, there's dashboards as well that do that. So.
Yeah, I'm just referring because some people, well, they think, oh yeah, and then you use a container and a cloud, so then your resources are unlimited. You can always scale up at 1 second and then you're done. But
yeah, no, that doesn't work.
Yeah.
So no, you still need proper capacity management and monitoring.
But it doesn't change, although you.
No, but in this case, you can give tenants or people a quota, and then they will run into their own limits. So and they're not bothering somebody else. So if I give you,
it might be the same as Amazon.
Yeah, that's not specific to the container store. So
no.
that's the quota or tenant management that you get with OpenStack as part of OpenStack, and that secures against noisy neighbours taking each other's resources. And then as an operator, from your point of view, as the person delivering the overall stack, you need visibility to know whether you're running out of resources and need to expand the cloud to give more quota to individual tenant groups. That's kind of the circular conversation.
Plus you can burst into public cloud.
Yes, if you integrate into a hybrid.
Yeah, that too. And you can also, you can burst into our other product, which is called SUSE Containers as a Service Platform. It's basically just hardware with unlimited containers on it. So there's lots of things you can do. But
yeah, and of course the main difference is also that you can add new hardware and then you can spin up containers.
That's what.
Opposed to install your OS.
Yeah, that's basically what the whole software-defined infrastructure is about. You've got your infrastructure blob with all kinds of things. At some point it's full. You just buy new machines, connect them, spin them up, and you've got extra infra. And since it's all software-defined and very fluid, it will just be added and be usable. So that's what all the distributions are about, making it easy for you to add all new infra to your software-defined infrastructure. So, SUSE OpenStack Cloud demo. It's a bit of an improvised demo because of how the video setup here doesn't work with anybody's laptop except for this one. I do not have my laptop, so I'll show you something else. Sorry? Ik weet niet wat dit is. Staat Core i7 op, ja. So, are you looking at? Yes. Okay. So you're looking at the same as I am. So, this is what SUSE OpenStack Cloud looks like. Everybody's seen OpenStack clouds by now, I guess. So you've got your compute normal menu, but we have a container infra menu where we can make cluster templates. So we can make. We're going to deploy a cluster. 5 minutes? Okay, cool, thanks. We're going to deploy a Kubernetes cluster in OpenStack. So we will call this Spant 1. We want to, want to use Kubernetes. These things are not very relevant at this point. We get an image which is used to install the OS on the virtual machines. In this case, we define the size of the machines that are going to run the containers. So this is where the sizing comes in, and one Magnum has It's probably 2 CPUs and some memory. If I go over quota, it will complain. Bit of persistent storage. These are just not very interesting bits, but I have to fill them in. Now wait 1 second. I want master load balancer.
And who will typically do this? Job role?
This is your OpenStack OpenStack admin. Because as you saw here, I can make this public. So I can make the template, and then the tenants can see this template and they can roll it out.
Yeah.
So I'll make this public, just for fun. So I create my template. So now I have a template, what things should be used and what size of machine should be used. Then we go to clusters, and I can create a cluster. I'll call it Spant 1 as well. I will use my Spant 1 template, and I can decide the size of the thing. I will have 3 masters. Because of failover and high availability and all that, I'll use 3 masters, and I'll get 5 minions. So that's 5 nodes where the actual Docker containers are running and doing all the work. And I'll create that. And then I'll go to the nice picture page. So this is all the things that you would normally have to do by hand. So these are routers, hosts, firewall rules, switch ports, IP addresses, load balancers are in there somewhere. So these are all being created at the moment. This is all the hassle that you're saving yourself with using templates, using Magnum and Heat. So once this is done, in the end, you have your Kubernetes cluster, you get your configuration from the cluster, and you use all your normal Kubernetes tools that you're using to do all your Kubernetes magic. And it runs in your cloud.
What's the difference with the CAS you mentioned?
CAS is the CAS is just hardware. It's hardware and then micro OS layer and Kubernetes. So it's an extremely easy installer that if you have like 5 or 10 bare metal machines, you can take 15 minutes, and in 15 minutes, those 5 to 10 machines will all be running a big Kubernetes cluster and containers.
So CAS is Kubernetes enterprise grade.
Well, this is enterprise grade as well, but this runs in your OpenStack. That is just Kubernetes. If you don't want to do the whole virtual machine and you don't want to do OpenStack, but you just have a containerized workload, you can use CAS, and then you just do containers. That's it. It's just a very easy, fast installer to get a massive container cluster.
There's also presently some weaknesses around management of disk and networking in the standard Kubernetes containers thing. So OpenStack can help around that specific business need. But if you come to SUSE, we'll direct you to either one. So if you want to use containers within OpenStack, and that's the best use case, we'll help you explore that. But if your use case actually is going to be better with the standard alone Kubernetes cloud, we'd work with you on that as well.
But if you already have an OpenStack environment and you want to use containers as well,
yeah,
this is the way to go.
This is the way to go. That's why the talk is called OpenStack.
Silo of just containers, and in that case, then the containers as a service platform solution works as well.
Yeah, because Kubernetes is not easy to install, and it has some things that you need to take care of. And we've got a couple of very nice German engineers that did all that work for you and made a very nice installer around it. So, and obviously it's a distribution that comes from us. So we say it's enterprise ready. We support you. We give you updates, and we say it's enterprise ready. You can run your bank or hospital on it, or in our case, aircraft company, or I don't know, auto company. So
is it SUSE technology or is it OpenStack technology? I mean,
the containers as a service.
My rent is also offering the same set of features.
Well, containers as a service is Kubernetes. It's like the Linux distribution is a Linux kernel and Linux packages, and we made a distribution out of it. Containers as a service is a Kubernetes cluster that we made a distribution out of it. We productize it, as Simon likes to call it. So.
But when you buy a Red OpenStack or a Marentes OpenStack or something like that, you also have that functionality.
Yep. Yes.
Okay.
Yes. So this is, the OpenStack is just based on upstream OpenStack, and the other OpenStacks also have Magnum and Heat. So
There are some differences when it comes down to management tools around the core distribution. So we have Crowbar, for example, for the administration of the OpenStack, and it has something else. Also support of hypervisor is different. So there are differences, but the core technology is open source. It's the same. Red Hat, it's SUSE.
yeah. So this is our architecture picture. Basically, software-defined everything, containers as a service, or cloud, and then you have Kubernetes and Cloud Foundry. So we have some slides about containers as a service, which is not that we were just talking about, but yeah. Well, Jacco, you talk to me on LinkedIn en we'll have a chat. Even LinkedIn en dan leg ik het je wel uit of ik kom het een keer laten zien. Oké. Dankjewel.